So, taking some questions. First on the current web work. It's so nice to see you back. I don't know, I missed you.
Nice to do.
Yeah. So, yeah, let me get the right glasses on. Josh, let me start with your question. I think Kitcher's got one, but let's start with yours, sir.
Mine was number 2.
Number 2, okay, cool. What was that question?
Well, the problem is 1.
Wait, can I see it? Let's see. I don't remember what it was, but was it
1/7.
Oh God, yeah. Okay.
Yeah, it just wouldn't work when I try to plot.
Yeah. So let me show you some stuff to help with this. So Josh's problem looks like this. That's A sub n. And I think that sequence app I gave you isn't precise enough
Yeah.
to detect this.
I tried to use Desmos and it was the same thing.
It's the same kind of pain in the ass. So what I would recommend, excuse me, thank you, is let me show you how to do this in Excel. Let me show you, oh God, now I gotta wait for Regis' computer.
Does it work in Google Sheets?
Yeah, it would work, yes, Google Sheets, any sort of spreadsheet would work real good. Oh, what a clown show, my God. So I might hold off on this one while the beast is warming up here. What did you call that problem, Lou? The monster beast?
Yeah.
Yeah, so the monster beast of Regis Tech. You suck, Regis Computers. Okay, so we'll come back to that one, Josh, because I need to get a spreadsheet to show you how to do that. What are some other problems we could look at off that web work? Not the new one. This is the monster beast. Okay, beautiful. Okay. So this number 4, Lou, is that the, yeah, the friend, our friend. So problem number 4, we've got a sequence, and I can do something like this. A sub n is, let's see, so 5n plus 1, whoa, 5n plus 1 over 5n. Minus 5n over 5n plus 1. Lots of questions about that sequence. So first things first is it bounded above by a number? And I believe the answer is probably yes. But what you need to do is actually look at how the sequence behaves. I'll come back and keep grabbing those, Vivian, thank you. So I would actually look at the sequence, and if you had Excel, it would probably make it a little easier to see precise values. Let me see how we're doing over here. Oh, I'm logged on. Unbelievable. Unfreaking believable. I didn't cuss either. All right, so, yay. Okay. Did that computer come on? No, there we go. I think doing this one on Excel, both these problems on Excel is going to be a road to happiness. If the computer can find Excel, probably have to do something really stupid like find it in. How can a computer not have Excel?
It's really new.
That is not a problem we have at Regis.
Really?
Yeah, that would be great. This thing is powered by squirrels, so, okay, I'll just go to Google Sheets, Lou. I like that idea. So, because it'll work the same. Can I just get there without having to like log into Google for free? Just go to the damn sheets, there we go. Oh, criminally. So, sure.
What's your middle name?
What do you think it is?
James?
Yeah.
Jeremiah?
Timmy Jimmy.
Wait, really?
Well, kind of, yeah, I mean, yeah. But,
Jimmy?
yeah, it's Timothy James,
Okay.
but it could be known as Timmy Jimmy, luckily.
Timmy Jimmy?
But I changed it, when I got married, I changed it to Jasper.
Did you ever go by TJ?
Oh, yeah. I go by T a lot, just in general. But yeah, when I got married, so it was my father's name, and not really a fan of his for lots of reasons. So my wife knew that. She was also estranged from her father. We grew up in single-parent households. Fathers left, you know, left us all on our own to survive, and so we both had great feelings about our father. So she gave me a middle name Jasper, and I like that way better. That's way cooler, right? Timmy Jasper, Timmy Jimmy.
Timmy, Jimmy, Timmy.
All right, come on, Google. I hope I know my. You, everything. Why do I still get hacked? How can I possibly still get hacked? Okay, just do the shit. Send me. Oh my god. Okay, so what do I have to do? Go to this stupid Google app, right? Google. Oh, look, it's working. Amazing. Allow. Yes, it's me. Okay, great. Oh god, now you can see all sorts of weird stuff that's in here. I just want a blank sheet. Luckily there's nothing terribly dicey, so that's good. Alright, zoom in. How do you zoom in? Who knows? Okay, so spreadsheet 101, working with sequences. This is some nice skills that aren't just useful for this assignment, but useful for life stuff. Because Excel is one of the great gifts Microsoft gave us. Excel is a wonderful thing. I love Excel. So, I want to do a sequence. I'm going to take this first column and start entering 1, 2, 3, just a couple, just enter 3 there. This will be on the recording as well. So, let's do this. Let's go back and do this one while we're at it. Can you see that okay, Josh? Yeah.
Yeah.
You just look like you were having trouble seeing it. So in my first column, I'm going to put the n, and then I'm going to put the a sub n here. So I've got 1, 2, 3. And now over here, I'm going to type the formula for the formula, but point toward this cell. So in Excel, across the top you have letters for the column, and then on the left side you have numbers for the row. So this is cell A1, this is cell A2, this is cell B3 right here. So what I'm going to type into here is equals 1 over 7 times n, but n is this cell right here. So I'm going to type A1 squared minus 896 times, and I'm using the computer notation, pointing back to the n. This is my n, A1, plus 52, and then I close that off. So I would type it in literally just like that, and it would spill into this next column, so it's no problem. Hit enter. So let me do that right now. So equals, and you can do this along with me, especially for your particular problem if you have Excel. So 1 over 7 times. You got to use that asterisk for times. And then you can click on that cell, A1, to get it to enter, or you can enter A1, all good, either way. Squared minus 896 times cell A1, so this time I'm going to type it. Notice how it's showing up in a different color because it's an active variable. And then plus 52. And then close off the paren and hit enter. And so now I see the first value for my sequence right here. Is there a zoom down there? Yeah, it looks like it. Let's zoom in so that we can all see this, because that is painful. I mean, you don't have, your eyes are like a third of the age of mine. So,
If you go to the like 100% column,
Up above B.
up above the B. Oh, I see, thank you. Okay. So let's go 200 at least. Oh, so much better. Okay. It looks like it's already, this thing looks a little smarter than Excel, but what I'm gonna do is click on that formula, and then notice down here there's a little button on the right corner. I can grab that, hold down the mouse button and drag. And it fills in the formula with this active reference. So now instead of using this cell, it's using this cell value. So it's kind of a dynamic variable. Look, I'll click in that cell and you can see it changed it automatically. So can you see? Yeah, it's really hard to see it up there. God, that's tiny. But this cell, in this cell now, it replaced the A1 with A2. So I can drag that down a little further, and then I'm going to show you the amazing part. So take this and drag it down. Cool. Now, I want Excel to repeat this pattern, so I'm going to click in this 2, I'm going to hold Shift and select all those cells. Holding Shift selects a range. You click where you want to start, hold Shift, click in the end, and you can do a whole column, or you can do a square or rectangle, whatever you want. Now, see that heavy corner, that little dot? I'm going to grab that beast, and I'm going to drag it as far as I freaking feel like. And it's going to intelligently fill in all those columns for me. So I now have a picture, I now have the values for my sequence. And at this point, I can answer that question. So this question is asking us, when does this sequence become eventually monotone? So the sequence goes something like this, I think, right? It goes down for a while and then it starts to go up. Is that, or is it the other way around? Well, let's take a look. So yeah, it starts off at 1,300 thousandths, and then it goes to negative. Oh, so it's going up at the beginning because those are negative values and they're becoming less negative. So it's actually going something like this, and then it's becoming. What is it doing here? My God. So we're getting closer to 0. So we're actually becoming less negative. Let's keep scrolling down, becoming less negative. See, there's a 3 there now. And now, look, now it started to bounce back up. So notice how it was going down, 3, 6, 3, 6, 9. What is it doing? Let's get a plot. I'm gonna plot this thing out. I'm gonna show you how to do that. So you select all those cells and then you hit Insert and Chart. And, oh, kind of. Didn't really give me much option for how to plot this thing. Sorry, I can't see squat here.
in the chart type, you can change what it kind of is.
Oh, it's so much easier to see over here. Yeah, I want just a dot chart. Thanks, Kendra. So, can we just give points like that? Yeah. Oh, okay. That's not a great plot. Oh, aha! Look, this is helpful. Holy smokes, I'm glad I have this plot because I didn't think it was out. So it goes up, goes across, maybe keeps going up, and then it drops down over here. And there's like if you were to plot this out in Desmos, there'd be a vertical asymptote right here. If you were doing this in just a normal plot, there's an asymptote right here. This is not monotonic because this goes up and then down. From this point on, it's monotonic decreasing. So the graph is kind of like a parabola, right? There's something like this and then a hyperbola, something like that going on. We just got to figure out where that cutoff is. And then it's monotonic from there on out. Let's see. So that looks like 130-ish. Let's go down to 130 over here in our data set. All right, so what do we got? So, oh yeah, check it out. Here's where it's negative and then it jumps to positive. And then once it jumps positive, it starts decreasing from there on out. So Josh, I would say for your problem, It's monotonic from n for n greater than or equal to 128. Does that make sense?
Yeah,
That's intense, isn't it?
very.
Yeah. So it's like some serious science and getting in there and digging in. So then, what was the other problem? Oh yeah, this one. We can do this one now. I'll get another sheet out and do that one. And I can help you all do this with Excel if you need help. Let me grab another sheet. And let me do the current one.
That's not correct, but.
It's not? Huh.
This is what I wrote.
What's your graph? Oh. Yeah, it's kind of the same thing. Yours is a lot sooner, though. Yeah. Josh, could you plot yours in the sequence? Oh, Cassie's got a really nice one. That's Excel, isn't it?
Mm-hmm.
See, I couldn't get my Excel to work. I don't know.
That's okay.
I don't know what I did wrong. Like, I took the parentheses out too, but
Okay.
it's not making a formula.
So you need
Oh, yeah,
128
no,
here.
I
You did that.
128, 127, and 129.
Okay, well, let's try 126 just for the hell of it.
Yeah.
Okay, yeah, there's one too many ones. 126, and then submit. What the? Did I enter the problem right? In 96 and 52? Huh. Can we go to the little sequence thing? Could you do that for me, please?
That's not good.
Maybe we should get Cassie to enter. She's got a sweet graph. Well, you have to change the whole thing. That'll be a pain.
You want to use this one? The,
Yes, sir. Oh, that, yeah.
Cassie, what point did you pick?
Not this one, sorry, the very top one.
okay. Give it a breath.
Cassie's on tech support, math lifeline, and put a paren, yeah. Yeah, good stuff.
Need another parentheses, right?
No, I think one will be good, but
Oh,
it's
really?
okay.
I was gonna do it for
2 won't hurt.
7 squared.
Oh, you don't need to do that.
Oh, you
I
don't?
think.
Not on
Huh,
this one?
No,
Right.
sir.
Okay.
Yeah, it's okay though. We can have double parens. Not a problem.
And
And then
minus
896 and well.
Yes, this is
Well,
my problem
well.
before.
Okay. Oh, okay. Ooh, look at that. Boy, that's weird. Can we just scoot that thing? It just dies, huh? That's just freaking weird. What a bunch of garbage. I'm gonna cut and paste this really quick. So let's see. So Control C. Let's just look up a sequence here. Sorry, I'm just gonna look
I'll
up.
use Desmos. I don't know if that.
Oh, okay. Yeah, Desmos can
But
help us. Let's get on
This is the
Desmos.
one I was using before, and this is the exact problem. And it,
Oh, okay.
it did the same thing. So this one went to 300 values.
And then it just barfed.
Mm-hmm.
Oh, well, it's because I think this is only going up to n equals 300. I think
Yeah.
that's part of the problem. So let's fix this.
You wanna change
So
that?
it goes to
Oh, yeah. Good document.
technical difficulties for Desmos. It's saying, oh my God, oh my God. Okay, let's just do this without anything funky. Yeah, let's just do that, and let's just plot it like it's a function. So
So y equals.
y equals, and then let's do an x for the end. You can help me. Can you help me out, please, Josh? Okay, just the one. Yeah, change those to x's.
X 52.
We're gonna have to zoom the hell out.
Out?
Yeah, out,
Or in?
out, because it's super big.
It's at 10,000. 30.
Yeah, I don't even see a graph. I don't even see a pic. Oh, click that. It's not turned on. There we go.
Oh, okay. So now if I zoom back in.
Yeah, so
What
now
is
we.
it turned on?
Oh, I'm not sure. I don't know how to explain it, Lou.
Probably should refresh the page.
Yeah, let's do that. Let's just copy that before, so God, we don't have to type that shit in again. Okay, good. Control C.
I'm just gonna.
Yeah.
I'm
Yeah,
gonna
just
do
home,
Desmos.
or you can hit home.
Oh.
Yeah, home is also good. That should like reset everything.
Oh, okay.
Ah, so now zoom in. Yeah. There we go. Now we're seeing something. Okay, so let's scroll.
Keep going.
Yeah. So we're seeing it come up. Oh boy. Cute. You're not. I'm not doing that, am I?
No, yeah.
Was I doing that?
Yeah,
I thought you were like gonna
yeah.
let me pretend I was doing that.
No.
Thought that was very kind of you. Kind gentleman. Oh shit. Zoom out more. There we go. Ah, look.
Wait, it's not 128 though. It's like.
There we go. We found it. So from here, let's see. So it looks like from 128 out, it should be monotonic.
That's not what.
Yeah, I
what
still can't
work
get the
said.
answer.
Unless it goes back up again somewhere. But
Oh my gosh.
no way. Huh. Let's factor that thing. Let's factor this stupid polynomial.
Yeah. Please.
You can do it. Yeah, I'll do it. I'll do it. I'll show you some. I'll show you the dark secret of everything. Wolfram Alpha. You ever been here?
No.
No,
Man,
never.
for showing you
Never.
this.
Ever.
You can type in anything and it will answer it. So what?
Never
What
been
is
there
love?
before.
Let's see what happens. See, it answered it. It's got all sorts of answers, but it does math more importantly. So factor that polynomial 7, and I'll do an x. So 7x squared minus 896 x plus 52. And okay, so then it factored it for me. So let's see what we got. Pretty gruesome. But it's showing us that same plot again. So it is like kind of a parabola. Oh, yeah, let's turn it upside down. No. That should work. So here's where the asymptote, so this is not the reciprocal. The reciprocal is what we have. So whenever it hits 0, you're going to get an asymptote. So when you take the reciprocal of this stuff, it's going to be negative, and then there's going to like be asymptotes right here, and then it's going to be positive. So honestly, it's got to be where it's positive, and then that should be our answer. So I don't quite understand what the problem is with that problem. I'm really regretting assigning it, since we're like,
Pick it up.
has anybody got,
What does what work say the answer is?
it's just, it's really, it's a cursed day. Let's see here. Let's see, maybe if I got in here and just shook it. I hope that nothing, I hope I don't break it. I hope that I don't break, what problem is that? What assignment? That's-
Number 2.
And that's homework 7?
8.
8, homework 8. So if I went in and I said edit, and then.
Not edit, delete.
Yeah, let's see, wait, that's wrong, problem
Action.
editor. So homework 7, we gotta go back.
Would you be able to look at one of ours and see what the answer is? So maybe that would help the rest of us.
Yeah, do mine.
What is the, what,
'Cause
oh,
I
I
can't-
see what you're saying.
To see like what the value
Yeah.
might be.
There's all sorts of ways we could fix this.
Because I've tried like a whole number of like along that
Yeah,
area.
let's take a look.
and none
You're
of
right
them
about it.
really
I'm
did.
with you. I think that's smart. So we'll edit the problems and let's see here. Progress. Who doesn't mind me looking at their?
Oh, me.
Mine, I have
100%.
mine.
Okay.
Mine, I have none.
Everybody requires
If I can even find
Show
it.
the answer.
Do mine. Click it.
Oh, here.
Her
Here's
name
someone
is
who's
right
not
there.
taking the class anymore. Okay.
You
Is
should-
that yours,
to me?
Cassie?
Yeah.
Okay. Okay.
Ooh.
Okay, good lord. Okay, and that's problem 8.
2.
2. Okay.
I tried many different answers.
3.
Okay, wait, no, that's not showing the right answer yet. That was guesses.
Show correct.
So correct. Show
I've
correct
tried like
answers.
20 different answers at this point, it seems like.
14.
How is it 14?
What?
I know, we're deleting this shit.
Wait, what is my correct answer? Like,
Okay.
I actually
Yeah,
want to
no,
know.
you-
I am curious.
We would do
Okay,
it.
let me
You're gonna
look.
see this now. You have to check everyone.
No, I'm not doing that.
That'd be so funny. It says view student progress by set. Oh wait, full name. Just kidding.
All right, so let's see. So homework 8. Jesus, I cannot see it. It's like so sad.
22 and 10.
Problem 22 attempts. That's painful. So correct answer. Check answer.
64?
What?
What?
This is garbage.
It's going
It's
with
half
the
of it.
first part, not the second part.
Oh, it's not saying like ultimate. It's saying if you were to look at
But
it.
that's
Yeah.
not what monotonicity is.
Yeah.
So
Yeah, I don't know.
Yeah.
'Cause mine's in the area where it's going like
Oh, the
this, it's
passion
going
coming
down,
out
it's where it
there.
like
Get
starts.
outta here.
Yeah, going
yeah, no,
flat
fuck
again.
this problem.
Yeah.
Yeah, screw the homework.
All right, you don't have to do that problem anymore. Thank God.
How did you get this?
What?
It's because it's in the first part of it, it doesn't go to the second part, where it goes back up.
Yeah, which doesn't make sense because it's actually lower. That's not monotonicity. That's not. Well, that was pretty painful.
It sounds like web work doesn't know what math is.
I think you might be on this.
Oh, what work knows.
All right, so
Decimal.
that was problem 2. Yes.
Yes.
Okay.
If I refresh my page, will it disappear?
Automatic. Force numbering and. Let me just make sure I don't do anything weird.
There's only one. Don't forget one. Can we do the other one?
Give it another 4.
Hold on. Delete it. Save changes. It's gone. I'm not going to delete. I don't think any others deserve deletion.
We'll see about that.
Does it work? Is it gone?
Oh, yeah.
Yeah,
it is.
Okay. Let's look at this one. Let's look at this other one. This one here. So that one should work. So let's see. So 1, 2, get started, 3, and then this is going to equal. You know what I would do with this is actually simplify it first because it's just so easy to simplify this fraction. All right, you got these. Bring these two together. So this is going to be multiply this one by 5n plus 1 over n plus 1, and this one by 5n over 5n. So we got 5n plus 1 times 5n plus 1 minus 5n squared over 5n times 5n plus 1. And then that's going to simplify out. Let's see, so you FOIL that. So it's going to be 10n plus 1 over 25n squared plus 5n. That's much easier to deal with emotionally and everything. Is that
Is that easier?
right?
Wait.
Yeah, that'll work.
How did, I have no idea what you just did.
I combined these two fractions. So I just added those two fractions. I got a common denominator of 5n times 5n plus 1.
Oh, okay.
And so I multiplied this one by 5n plus 1 over 5n plus 1.
Oh, okay.
And then that one by 5n over 5n. And then that actually looks legit. Because the limit should be 0. So what are the things, why do we even need Excel for this? Was it, what are some of
Because
the?
there's like 3 or 4 parts. to
Yeah,
it.
can I look at those 3? You got it right here?
Mhm.
Thank you. Let's see.
There's sequence bounded.
Oh, bounded.
Monotonic.
Yeah.
Does it converge?
Okay.
Conceptual questions.
Cool, okay. Ruby. So yeah, so to see if it's bounded, we would like to see some values. So let's see, so this is going to equal 10 times the index, so 10 A1 plus 1, then close the paren, now put the denominator, it's going to be 25 times. Probably not going to be doing a lot of new material today. Is that okay?
Yep.
Is that okay? N squared plus 5n. Oh, why am I typing n? Because I'm a Timmy Jimmy. S squared plus 5. Such a timmy Jimmy. All right, so then now I can copy that formula down and life should look better. Okay, cool. That's looking very monotonic to me. I don't expect it's going to jump up, but it might. So select all that and drag.
Error.
Error.
What did you do? Oh.
Okay, that looks super monotonic. That looks like it's decreasing completely. So what's the first question they ask? Let's see, anybody? What was the first question we have to ask? Is it bounded? Yes. Is this bounded? So first off, is this thing always positive? Let's talk about it. Yeah, right? Definitely always positive. Is it monotonic? Looking at those values. Seems like, right? Yeah. Right? It's always going down. So monotonic. So if it's always stuck above 0 and its highest value is its first one, what is it bounded by? Bounded by 0 below, and then what about above? The first value. So this thing is bounded below by 0, but it's also bounded above by just when n equals 1. So 11/30 would be an upper bound. But do they even ask for the bound, or just ask, is it bounded?
No, they ask for, they ask for a number.
They ask for a number. So anything above that first number should work. They're not asking for the best bound. So like 1 should work. Bounded above by 1, bounded below by 0. And then what's the second question? What else? So we got.
Is it monotonic?
Is it not?
Oh, monotonic. Yes, you got, yep, and that's checking out, right? Okay, cool.
Does it converge?
Does it converge? Does it converge? What is the limit of this? If this were just, well, it's going to infinity, like n is going to infinity.
1 to 0.
It's 0, because this is, look, check this out. This is a L'Hopital form. Top's going to infinity, bottom's going to infinity. Do L'Hopital's rule. Take the derivative with respect to n. 10 over 50n plus 5. Top is fixed, bottom blowing up, that goes to 0. Yes, cool. What else we got? We're taking down the monster.
Conceptual follow-up questions. There's different equations. So this one
And is it the same as the original, just with some changes on it? No? Oh, it's totally different. Yeah. Okay, should we look at those?
That'd be nice.
Okay, got it. All right, let's do that. Let's take a, yeah, I think we can end this Excel expedition for a second anyway. I'll leave the computer on, for God's sakes. So the second part to that problem, Kitra, would you please read me that first new sequence?
Yes. -1 to the power of n times 10n squared plus 1 over n squared plus 1.
Plus n?
Yeah.
Thank you. Cool. All right, let's look at this. What does this -1 to the n thing do? Flips you, right? So you go plus minus, plus minus, plus minus. And that never ends. Where is this? So without the -1 to the n, let's just look at this piece. Where is this going? As n gets bigger, where does this go? It's one of those rational functions, same degree on the top and the bottom.
Oh, isn't it just
10. Yes, it's the ratio of the leading coefficients because it's the same degree. So does that make sense to everyone? And if not, let me explain it. That this goes to 10. Because when n is really big, it's just like 10 to the billion, or 10 billion over a billion, right? Plus some little twiddlies here on the side. So this thing's going to 10. You could use L'Hopital's rule to see that. 2 applications of L'Hopital's rule gets you that limit quite easily. So in the end, this piece right here is going to 10. So the sequence is like clicking out, and eventually it approaches 10, way out here. But what is this doing to it? So this piece is essentially, this is approximately 10 when n is large. What is this doing to it? Alternating it. So this chunk here goes to 10, but then it's out here. That piece is going to make it go 10, minus 10, 10, minus 10. Does that converge or diverge? That is divergent. It is not settling down. If this piece had gone to 0, then we'd be cool, because it'd be plus minus a thing that's dying out. But the fact that it's approaching a constant, and then that constant gets flipped, that's what's messing up the convergence. Does that make sense on that one? Yeah? And what else we got?
This last one. Well, that's what I can tell.
Oh, okay, so for that one, we've got something like this. 10n cubed plus 1. It's kind of like this, but the top power is higher. So here we've got a thing that's blowing up on top faster than on the bottom. Let's L'Hopital it. It's certainly doing this, right? That's going to infinity, that's going to infinity. So one application of L'Hopital on top gets me 30n squared. The bottom I've got 2n plus 1. Still, I've got infinity over infinity. What I'm hoping is to get one piece of this constant, and I'm going to get that with one more application of L'Hopital's rule, because the derivative of the top is 60n, the bottom is 2. So that actually simplifies to 30n. Where's that going as n goes to infinity? Infinity. So that is divergent.
And then bounded, unbounded.
So if you're blowing to infinity, can't be bounded, right? Because yeah, there's no cap on it. Absolutely. For monotonicity, you probably need to like do some Excel work to check out the values. Yeah. Is this one, is that one over there, is that monotonic, that one on top?
No.
No way, right? Because that's totally bouncing around forever. So, what else we got on that one, Kitcher? Is that about it, or?
Yeah, it's like the concept questions of like what monotone is, but.
Got it. Cool. Does that feel okay to you? You will notice there's a new web workup that was supposed to be due Wednesday. That is not due Wednesday. We kind of need to talk about it. Yeah, trash and homeworks left and right. Burn them.
Keep going.
Burn it all down. Yes. Which one? I'm sorry, which one? The one on top? I'm sorry, but that is not bounded, because if you blow up to infinity, you're not bounded. Yeah, it's going up.
And then
It would be divergent. Well, that one you need to get, that one you'll need to do Excel, because I'm not 100%, but get the, yeah, check out a spreadsheet on it. Does that sound good? Yes, ma'am.
I'm horribly confused.
Uh-oh. All right.
So I put in, this is where I like to do so.
Cool. Okay. That's, something's a little off. May I take a look?
Yes.
All right, so let's see here.
Maybe I simplified.
Okay, yeah, let's check your simplification. So, yeah, something is off. Can I see your work for that simplification?
Oh.
Yeah, let's do it together.
Did you put it into Excel? Just Excel?
Oh, I see what you did wrong. I think the top is gonna work out. This whole bottom is, see right now, you've just got division by 2n, and then you multiply, that whole bottom needs to be in current. So You see what I'm saying? Yeah, so like a pair of parentheses around the whole denominator. There, a lefty there, and a righty there. Beautiful. And then propagate that change. And you can just, actually you can just go over here. You don't even need to do for, yeah, either way, it don't matter. Because you've got the first column filled in already, so it doesn't matter. That'll be good. Okay. So now you've got values that actually seem right. And it kind of looks like it's always going down to me, right? So, yeah, does it kind of seem like it's always doing that? Just super slowly, but yeah. That looks pretty kosher. So what is it bounded above by? So it's always going down, and it's always above 0, but what is it always less than or equal to? Yeah, and what is that first value precisely? So I think we should give, you can actually, let's try 1. 1 should work, because it's not saying the least bound, so let's try, let's check it. Check, let's see if that's even remotely happy with our efforts. Okay, good, good. That'll work good. Correct. Yes, ma'am. You feeling better here now?
Yes.
Okay, awesome, good work. Daniela, you doing all right? Ah, okay, all right. Good, I finally get to help you with something. Yes, ma'am. Oh, okay, let's take a look. So, oh, just like the dragging and stuff? Okay, so that all looks good. So I would click there and then hold shift and click there. So see how there's that little dot in the corner and grab that and hold. I'm gonna let you try it here. Just try like grabbing that corner and see. You gotta hold down on the. Yeah, keep pressing that while you drag it. That's the click. There you go. Okay, go back up. Oh wait, it's a little too much. Yeah, just. That's it. It's hard. It's really hard without a mouse. I using those touch pads in this, like I find really painful. It's kind of like a video game, almost. Terrible, terrible video game. Try zooming in a little more, so you've got a little slightly bigger. There you go. Oh my God. There you go. Oh, see how it turned to that plus? Go, keep going till it turned to that. Just move it around a little more left. See that? That's it. You got to get it to transform. Oh my God, that wasn't it. Wait, no, maybe. Okay, that should work. Oh God. Good, good work. Yeah, takes some practice. You doing all right, David?
I think so.
You want to discuss and you need consultation? Maybe?
Maybe.
Which?
I don't know if I'm hearing it.
Okay.
Just figured it out, so.
Okay, gotcha. Are you having trouble getting the Excel stuff going? or-
No.
Okay.
That's what I'm doing right.
Okay. Okay, I'll come back and check on you. Josh, how you doing?
I'm alright. I did have one question.
Yes, sir.
So, I finally got it right, but on this one, it asked, yeah, I want to show how it was monotonic, because looking at the spreadsheet,
Mm-hmm.
it never goes to a single value.
So monotonic just means, is it always going up or always going down?
Oh, okay. So it is monotonic.
It is
Okay.
monotonic. Yeah, does that make sense?
Yeah. Okay. It is unbounded, yeah. Never did. All right, thank you.
You're welcome, sir. Excuse me. Thank you.
So,
Yes.
okay.
Mhm. Cool. Good.
Yep.
Is it not liking your answer because you're using a decimal? Is that what, are you using a decimal approximation? No, what are you?
I don't know. I don't know.
Okay, hold on, let me go address this on the board. What problem is that, Kevin?
7.
Number 7, okay. Oh, you're fine, thanks. All right, number 7, there's an arctan. So number 7, got something like a sub n equals arctan, and everybody's got slightly different. We'll just do negative 11n, something like that. So the key thing to get the right answer here is you first have to remember what does an arctangent look like. So just normal y equals arctan of x has these asymptotes. That's pi over 2, and that's negative pi over 2. So when you see those asymptotes, that's what they are. Changing this thing inside here just first off flips it. So if you put a negative x in, you get this graph. But the asymptotes aren't changing. So you're probably getting something like negative 1.7 or something, right, as you move out that way. It's not liking that because it wants you to know that that's negative pi over 2 is the actual answer. So try that, Kelby.
It worked for me.
Did it? How many decimals did you use?
I used 2.
What?
I put 3 and it said no.
Oh.
That's, yeah, Katrina's having trouble with that, damn.
But we're
Yeah.
it's a little
But we're-
interesting.
And you ended up putting negative pi over 2 and it worked out?
Yeah.
Okay, yeah.
Odd. Business.
Wait.
What's that?
Oh, I get it. Oh my god.
You see now?
I almost, yep, I got it.
That worked too.
Beauty.
Oh, I guess
Thanks.
I entered what negative pi over 2 is, like as a decimal.
Yeah. Oh, yeah, that's,
So I entered the actual value of negative pi over 2. Oh, so it's this. Like this is what I
Yeah.
put as my answer.
yeah, that's beautiful. Okay,
I didn't
yes.
realize that.
There you go. Good. Hi. You're feeling a lot better?
Yeah.
Still tired, probably cashed completely, yeah. I gotta get my other glasses, sorry. I've been trying to do it with this damn long distance pair. Better. Okay. Yeah, you could totally do that, definitely. And use x instead of n, so. 0.9 to the x. To the x power. There you go. There you go. Nice. So yeah, move way out there and just get a look at your y coordinate. What are you approaching? And I think I might talk about this one with everybody. Yeah, no, like just click on the graph and see what.
Oh.
Yeah, that's what I'm saying. Yeah. So look at your y coordinate. Yeah. But it's, so it's, we're looking at the limit as x goes to infinity. Yeah.
I was like, yours says 20. And that's because.
Yes, yes. So you're looking at the output value in n is really big. Does that make sense?
Yeah.
Yeah. Huzzah. I'm going to talk about that one really quick. Which one is that, number 8? Yeah. Hey, on number 8, you can do a graph and probably get the answer, but it'd be cooler to have a deeper understanding, so let me just tell you something really quick. There are sequences, and this is actually what, in a way, Wednesday's going to be all about this. You've got a fixed number to the nth power. So if we're looking at the limit of this, or this sequence, and r is a fixed number. Just like in that problem, you've got a number that's like 0.9 or 0.7 or something. This has two possible outcomes. It either equals 0 if the magnitude of r is less than 1, and it diverges otherwise. I guess if r equals 1, it's 1. But that's the only other nice thing. But this diverges otherwise. So when you have something like 10 minus 0.3 to the n, this piece is going to go to 0. And the whole thing is going to go to 10 minus 0, or 10. If I had 10 minus 1.3 to the n, this here I have r is 1.3, and that just keeps blowing up. So this would diverge. Does that make sense? So that's a much better way to answer that question, and it'll, if you understand that, it'll help on Wednesday too, actually. Hey, Luke.
So shouldn't this just, be -1? There's a cosine in there?
So, did you plot that one out? And what did that look like? Yeah.
Like that?
Mm-hmm. So it kind of keeps on going. And actually, let's look at that sequence tool too. This will be a good one for that. Good.
Sequence tool?
Yeah, the one with the link in the world class, or just go to a web browser,
Browser.
and then just in the search bar type sequence plotter. Yeah, probably. I was thinking 2 words. Oh, no, it's not an address.
Not
We're just
that?
searching. We're just searching on sequence plot. There we go. So, yeah, try that one. Try that.
That one? Yeah, why not?
Oh my God, go back. That is some code. Kind of works.
Maybe not.
Is this a new? Are they making you like a new class or anything? I gotta talk to your coach.
Go ahead, on Monday. Monday is 3:30.
Oh, is it?
Oh.
Okay.
I found that geo.
Okay, cool. Okay. All right, good. So I didn't want them to do that to you.
Found the geo program.
There you go. That's way better. So you can get a sense of what's going on then. And then put parentheses around that whole bottom too. Yeah. Beautiful. Let's hit enter on that. Does that look like it converges?
No.
Hell no. No, that's a pretty nice plot actually. So, technical issues.
I did that,
There you go. Yeah,
I thought I did that.
I
but
think you thought you did, but maybe you did not. Yes.
Yeah, okay.
Good. That makes sense.
Also,
Uh-huh.
it's been wonky here. I did this thing, right? Just get rid of that. So I did that.
We both looked at each other.
So I did the, so I simplified that, right? So,
Yeah, that looks good.
and then I simplified it to that.
That's great.
Right?
Oh, it's okay, you can use lowercase too.
Really?
Yeah, yeah, it's totally case not sensitive. There you go. Cool.
So 45, right? I took that one and I put it there,
Okay.
right? Because
Mhm.
that, it's bounded.
That's not what it's bounded below by. I don't think you're reading those questions.
Oh. So it's bounded above by that.
Yes. And it's bounded below by 0.
Okay.
There you go. Now try that. You'll be a lot happier.
A lot happier.
So much happier.
And then
Yeah.
bounded uh-oh.
There you go. I think now it'll be happy. It's all those things. It's all 3.
All 3?
Well, it's bounded above by, yeah, I mean, yeah. Yeah, there you go. There you go. So if you say it converges, then you have to have a limit. The limit can't not exist. Yeah, yeah.
Wait, what part is this to?
It's kind of, keep going up. It's still the same, it's this
The same.
thing up, yeah, yeah. So it's the thing you simplified. You've got the nice simple form. I just gotta find the limit. No, that's just one of the values. That's the first value. But you want to be able to take the limit by looking at the equations. So that's what it
The
does.
limit as it goes to
As it goes, and it goes to infinity, yeah. Cool.
there. Is it 1? No.
What's the top going to? What's 8, if n is getting bigger, what is 8n doing?
Going to
It's going to, what's the bottom doing? Correct, so you've got an infinity over infinity, you can use L'Hopital's rule. So what's the derivative of the top? Yep, beautiful, what's the derivative of the bottom? Solid, now.
Yeah, so it's going to 0.
Yes. Oh, totally, yeah. You're welcome. Fernanda, I gotta give you, I never got you your exam back, so let me get that to you. I got it, I know I saw it earlier today. Oh, yeah. Oh, and Kelby, too.
Oh,
She's coming back. Thank you. Bye. See you on Wednesday. Cool. My lecture for Wednesday's written. Yay.
No need to worry about it
I
anymore.
know, exactly.
Yeah, you're feeling all right. Awesome, outstanding. I think I'm gonna sign you off here, recording.